It's not from me, but yeah.
Okay, we're going live. Hi, thank you for joining us for our next TED Talk. Today we have Dr. Francesca Lazzeri. She is an experienced scientist and machine learning practitioner with over 12 years of both academic and industry experience. She is the author of a number of publications, which include technology journals, conferences, and books. She currently leads an international team of cloud AI advocates and developers at Microsoft, managing a large portfolio of customers in the academic and education sector and building intelligent automated solutions on the cloud. And before joining Microsoft, she was a research fellow at Harvard University in the Technology and Operations Management team. So thank you for joining us today.
Thank you so much, and thank you for introducing me. Hi, everyone. This is Francesca, and I'm very, very happy to present this session today. I think the introduction was great, so thank you again. Just to share a little bit more about what I do right now at Microsoft. I lead an international team of developers, cloud advocates, and also data scientists, and we build solutions on the cloud. We mainly focus on customers that are in the academic ecosystem. So we work a lot with a lot of research institutions and also universities. And here in this first slide, as you can see, I share just a little bit more contact information. If you have questions, usually I always reply on Twitter. There is also a GitHub repo where I put most of the work that my team develops, and I'm also pretty active on Medium. Usually, if I have time, I also write a few short articles, short blog posts there. Okay, so let's get started. For today, we are going to see during this session why responsible AI is so important and what we mean when we talk about InterpretML, so Interpret Machine Learning, and Fairlearn Toolkit. Here, I just put some of the resources that I will be using during this session. As you can see, most of these resources are GitHub links. So GitHub repo where you can find most of the code that I'm going to show you today, and also some of the technical documentation that I'm going to share with you today. I will make sure to share all these slides with the organizers and with you all later. So no worries, you will have a very good overview of all the resources that we will use, so that after this session, if you wanted to learn more or just look offline at the different GitHub repo and documentation, feel free to do so and reach out to me if you have additional questions. So let's get started. So why we think that responsible machine learning, responsible AI is so important? I think that we all realize that leveraging data in order to make significant decisions that affect different individual lives in domains such as healthcare, as we were seeing in the previous session, but also justice, finance, education, marketing, honestly, all the different industries out there. It's important, but this is also affecting our lives. So it's important to ensure that safe, ethical, and responsible use of AI is applied. AI, as you know, has the potential to drive, in my opinion, big changes. And of course, if we use the right tools to make sure that the development of AI and I would say also of the machine learning algorithms that are behind each AI application, I think that we can bring, again, positive big changes. And so let's try to understand what we really mean when we talk about responsible machine learning, because it's a broad topic, and sometimes I have the feeling that, especially when I talk to customers, that it's a very high level, very theoretical concept. So let's try together to understand what we mean, and most importantly, how, as a scientist, we can apply part of this concept. So at Microsoft, as a foundation to guide our thinking, we defined 6 ethical principles that AI systems should follow. So as you can see from this simple diagram, the first four are fairness, reliability and safety, privacy and security, and inclusiveness. These are the key properties that each AI system should achieve. And then the second part, there are transparency and accountability that are somehow underneath all of the other principles and guide how we design, implement, and operationalize AI system, especially as a data scientist. So let's start with the transparency, and let's start to understand what we really mean with transparency. When we say transparency, at least in my team, that is a AI-driven team. So we mean that each systems that we build should be explainable. So AI system should have an algorithm accountability, meaning that each algorithm that we build or we leverage in order to build an AI application needs to be explained, not only from data scientists, but I would say also from the final users, the final customers. So there are different use cases that we have observed during these years, and these are use cases of machine learning interpretability, and we can define them in the following two categories, as you can see. So interpretability is touching both the model designers and evaluators. So this is more during the training time, and this is more like related to data scientists that needs to explain the output of a model to stakeholders, such as business users and clients, to build the trust. Also, we notice that the data scientist needs tools to debug their models and make informed decisions on how to improve them. And then data scientist also needs a tool to verify if a model's behavior matches pre-declared objectives. So that's why it's always very important to work very closely with data experts, business experts, and the people who really understand the field in which the AI application has been developed. And then finally, data scientists needs also tools to ensure the fairness of their trained models. So this is more like what we call that the training time, the experimentation time. That is really the moment in which data scientists or machine learning practitioners develop their applications, their machine learning algorithms and AI applications. But we also notice that there is a different moment in which interpretability of machine learning algorithms is very important, and we call it inferencing time, as you can see on the right side of these slides. And this is more about end users or providers of solution to end users. So this means that AI predictions need to be explained at the inference time. For example, if we build a healthcare application and we need to be able to understand as end user why the model classify Fabio. Here, Fabio is just a random name for a client ID at risk of colon cancer, for example. Another important sector that we work on every time is finance. So we have to be able as end user to answer questions such as why Rosine was denied a mortgage loan or why his investment portfolio carries a higher risk, if it is, of course, a finance application that is giving us that specific type of output, so like mortgage loan or not in this case. So there are a lot of use cases, and here I really try to summarize them in a very concise slide, but just to give you an overview of why AI and interpretable machine learning are important at different stages of the model development cycle. For this, we developed a tool that I'm going to share with you today. It's an open source tool. It's Python based, so it's related to the Microsoft principles that I was sharing with you today, but really we developed this tool for the community. It's called InterpretML, and it gives you access to, I would say, state-of-art interpretability techniques through an open unified API and also through different visualizations. So you can understand the models using a wide range of explainers and also different types of techniques, also using these interactive visuals. So you can explore, for example, model attributes such as the performance, global and local features, and you can also compare multiple models at the same time. Here, again, I put the link aks.ms/interpretml-toolkit, and this is the GitHub repo that if we have time at the end of this session, we will also look at together. Most importantly, I want to explain you what are the different components of this GitHub repo. So if you go there, you will see that that the InterpretML community was able to extend Interpret, that is this open source Python package from Microsoft Research. This Python package was developed for training interpretable models and helping to explain what we call the black box systems. And very soon we're going to see together what we mean with the black box system. And it was able to extend this with an additional interpretability techniques and also utility functions to handle, I would say, real-world data set and workflow. So with this package, you can train interpretable glass box models and explain black box systems. So this is very, very important to mention. Interpret helps also you to understand your global model behavior, so your model global behavior, and also to understand the reason behind individual predictions, so the reason why you are getting specific types of predictions. I would say that this is important for many different reasons. As a data scientist or developers, probably as many of you are, you can understand that interpretability is very important for model debugging. For example, why did my model make this mistake? But also for detecting fairness issues, for human AI cooperation. So how can I, for example, understand and trust these model decisions? And finally, also for high-risk applications, as we saw before, in healthcare, finance, also in the justice system, we have some applications that really affect human lives in a very, very strong way. So it's important to have these interpretability toolkits, or at least tools that data scientists can use. Just to understand how you can consume it. So this is an open source toolkit. The Azure Machine Learning SDK team build a sort of a wrapper around this, so you can save your explanation in the run history in case you want to look at the different history of your models, especially in the training time during experimentation. It also allows you to do remote and parallel computing of explanation of Azure Machine Learning compute, and then you can also create the scoring explainers, and most importantly also operationalize, deploy these explainers, these models. Finally, a last thing that I want to mention is that in the GitHub repo, you also will see that there is this interpret text builds. This is, again, it's an additional package that is great in order to understand better, interpret better your models that have been built on text analytics types of scenarios. We are not going to see that part today, but if you are a data scientist or a student who is really interested in machine learning for text data or for text analytics type of scenarios, that is also a very, very nice toolkit that you can look at. So in terms of models that are supported, I mentioned the glass box models and the black box explanations. So just to give you an overview of what we mean, glass box explanation are models such as, for example, explainable boosting, linear models, decision tree, rule systems. Black box explanation are like LIME, SHAP, partial dependency, also sensitivity analysis. So these are two different family, I would say, of models. And it's important to understand that the black box models are challenging to understand, for example, in the case of deep neural networks. And the black box explainers can analyze the relationship between the input features and output predictions to interpret the models. Some examples, as I mentioned before, are LIME and SHAP. Probably you are already familiar with these. For this session, I'm going just to explain the case of SHAP, just because of time. LIME is another great model, but we can keep that for another session. So let's take a closer look at SHAP. So SHAP is a game theoretic approach that is very, very good at explaining the output of any machine learning model. What I really like of SHAP is that it is able to connect optimal credit allocation with the local explanations using the classical Shapley values from game theory, so that is nice, and also all their related extensions. So let's see how we can apply SHAP to a real machine learning use case. So if you consider a very, very basic use case, so you consider a black box model that predicts the price of an apartment based on different typologies of features. In this case, we are considering the size of the apartment, if the building is pet friendly or no, and also the proximity to a green area like a park, for example. And this model is predicting that the specific apartment is going to the price of this specific apartment is going to be 300k euros, as you can see. So the main questions that we have as a data scientist, how much has each feature contributed to the prediction compared to the average prediction? So here we can see that, for example, the house prediction, the house price prediction in this case was 300k euros. The average house prediction, house price prediction was around 300k euros. So the delta here is about 10k euros. So these are the different values that Shapley and SHAP as an interpretability application takes into account. As you can see, there are different we can understand use SHAP that there are different features that were considered, such as the park, the proximity to a green area, such as park, was contributed to the price in a positive way, because it actually incremented the value of the apartment by 10k. The fact that the apartment was not pet friendly contributed in a negative way, so minus 50k. The size of the apartment itself, we can see that contributed to plus 10k, and also the fact that there was an additional features such as the floor where this apartment was located actually has a net zero contributions. So with the Shapley, again, you can have an overview of all the features that were in your model and how these features are impacting the different results. Just to give you again another overview is how really these work. And again, we took like a very simple example and we try to simplify it, but I think it's still great to understand the logic behind this. So how do we calculate the Shapley values? First of all, you always take your feature of interest, for example, the fact that the cats were banned because the building was not pet friendly, and you remove it from the feature set. Then you take the remaining features and you generate all possible coalitions. And finally, you add and remove your feature of interest to each of the coalitions, and you calculate the difference that it makes. So really, this is a process that it sounds like very clear and simple now, but this is really the process that usually you have to follow when you use a SHAP application, and so you want to calculate different Shapley values. In terms of glass box models, I'm not going into many details here. I just wanted to let you understand that this is also another great family of models that the Interpretability Toolkit supports. And just to give you some examples, glass box models are interpretable because of their structure. Examples are explainable boosting machines, EBM, or also linear models and decision trees. So glass box models produce lossless explanations and are editable. You can change them by domain expert. So this is again another great category of models that are supported by the Interpretable Machine Learning Toolkit. Another principle that I want to look at with you is fairness. So this second part of the presentation is on how this principle, fairness principle, can be applied, and what is the main question that this principle is going to answer. So how can we ensure that AI systems treat everyone fairly? So this is really the question that this principle is trying to answer. Fairness goal is actually to provide more positive outcomes and avoiding harmful outcomes of AI systems for different groups of people. So data scientists can use fairness in different ways. So this is a new approach to measuring and also mitigating unfairness in system that makes prediction and also serve users and make decisions about allocating resources, opportunities, or information. So let's share some practical examples. There are, I would say, many ways that AI systems can behave unfairly. For example, AI can impact the quality of a service, which is whether a system works as well for one person as it does for another person. And also AI can impact allocation. This is another area, so which is the harm that can occur when AI systems extend or withhold opportunities, resources, or information to specific groups of people. So this is again where AI and where fairness AI is playing an important role. Also, for this second principle, we develop an open source toolkit that really empowers developers of artificial intelligence systems to assess their system fairness and mitigate any observed fairness issues. So the focus of Fairlearn, that is this additional package, and by the way, you can look at it here. I put a link, aka.ms/Fairlearn AI. So the focus of Fairlearn is on different groups, and it really it's based on three different, I would say, steps. So first of all, it automatically analyzes a model's predictions, and it provides the user with insight into unfairness of their model predictions. And finally, the third part is that it supports algorithm methods to mitigate this type of unfairness. So if we have to look at the different arms that are addressed by Fairlearn, I would say that the literature and different data scientists and machine learning practitioners have identified different areas of fairness in machine learning and AI. So it's important to clarify that for now, the Fairlearn application is great at addressing only two of these fairness areas, that are allocation and quality of a service. As we said before, allocation is about extending or withholding opportunities, resources, or information for different group of people. And quality of service is whether a system works as well for one person as it does for another person. So the other areas of fairness or unfairness are not supported right now by this open source toolkit, Fairlearn. So in order to give you some additional example of what we mean with harm of allocation, here I put some of examples that honestly we observe from real customer scenarios. Examples of lending, for example. The data set describes whether each individual repaid the loan or not. And as you can imagine, we can build a simple classification algorithms that recommends whether a given individual should get a loan or not. So the train output in this case from the model should be yes, maybe, or no decision. The example of school admissions is another one that we have been working on. So the data set describes what was the first year GPA of each student. We build a regression, so it's a very simple regression use case. For a given applicant, this model predicts their GPA at the end of the first year. So the trained model outputs a real value prediction that is used as a score to screen applicants. The second part is about what we really mean with harm of quality of service. An example scenarios are news recommendation. So the training data indicates what article was presented to which user, whether the user clicked, and how much time the user spent on that specific article. In this case, we built a simple classification model that was able to predict which article to show to each user to optimize the click-through rate. So the trained model output was like a yes or a no decision. So in this case, honestly, there are two kinds of group fairness. One that is across users, so this is more about the quality of the service, and another one across publisher topics of articles. This is more quality of service, but also allocation. So this, again, just to give you an overview of what are the different applications that you can build and how fairness actually can impact the results that you get, and as a consequence, the final users that are consuming your AI applications. So now, let me give you an overview of what we mean with both, fairness and where you can find these different tools. So I will just stop sharing my slides, and here I just want to make sure that you have access to, this is the GitHub repo that you can find also under aka.ms/Fairlearn AI. But this is like the official GitHub repo with all the different examples and also the use case and the notebooks and the scripts that we put there in order for you to try them on. Here there is also a short description of what we mean with fairness, and honestly, my presentation is just a summary of all the work that we put here. So it's going to explain you very well, as you can see here, what we mean with allocation arms, quality of service arms, and so on. The most important part for this, I would say, is the notebooks. So I would really recommend you to go through these just to make sure that you know how to apply these different tools on your specific scenario. If you go also to the main website of Fairlearn, and again, this is all open source, you can understand better how you can quick start if you look, under quick start, you can understand better how you can install this package, and also what are the different types of visualization that you can get. So what is nice is that for each output, for each results, there is a correspondent dashboards or visualization that you can use not only as a data scientist who wants to understand better what's going on within the algorithm, but also to present your results to, I would say, data expert, business experts, so that you can explain better and in a, I would say, simple way what is going on. The last thing is that I want to show you is also the fact that here there is a very nice dashboard that you can use in order to understand, first of all, what are the different sensitive features and how the different performance metrics are used to evaluate the overall quality and fairness of your AI solutions. Since we have just a few minutes left, I will also show you how you can access to these. So in this case, I'm running my notebooks in Azure Machine Learning Studio. As you can see, my notebooks are all listed here. I just look for one notebook, and I already connected it to my computer. So if you open this, you're going to see that there is, first of all, let me go up. There is this notebook, and you can find this notebook also in the GitHub repo. That's why I'm sharing this. That is about mitigating disparities in ranking from binary data. So this is an example that is based on a dataset. It's a public dataset, so it's a real dataset based on the Law School Admission Council National Longitudinal Bar Passage. Basically, is a dataset that you can use because it summarizes the different data relative to students that were admitted or not to law schools. Everything is explain here what is covered. The last things that I want to show you is just the different mitigation algorithms that were used here. So you can see that here there is a data explanation. Here there is more about comparing probabilistic predictors using a dashboard. And here, once you use this Fairlearn application, you can just call the Fairlearn dashboard, as you can see here. And the last things that you need to do is just, sorry, I cannot, yes, we can look at this. You're going to have a dashboard visualized in your notebook, which is pretty easy and nice to have. And here, as you can see, is going to answer you questions such as along which features would you like to evaluate your model fairness. And here, for example, we had different features such as race. You can see that the two different subgroups, subgroups that we are evaluating is white and black. You can go ahead and, for example, you can see how do you want to measure performance. You can look at the different metrics that is here. Let's select the that metric. Let me make this a little bit smaller so you can see. And then there is also another nice part that you can use that is about the exponented gradient. So here again, it's another optimization algorithm that you can use in order to understand better what's the fairness level of your solution, of your AI solution. And the same is in terms of visualization. You can always call this Fairlearn dashboard to understand better what are the different features that are impacting the level of the fairness of your application, and how you can eventually improve your algorithms. I will conclude here because I know that we have only few minutes left. I will just share again all the resources that have been used during these presentations. And again, I will be very happy to share this slide deck with you all so that you can look at this offline and learn a little bit more, and let me know if you have, of course, any questions. Thank you very much.
Thank you so much for this amazing presentation. We'll make sure that all the links are available later.